Hey there. Today we'll look at polynomials, sum, difference, and products. So the objective is to understand what is a polynomial, okay? Understand what is a term, identify a monomial, a binomial, and trinomial, and then we'll look at addition, subtraction, and multiplication of polynomials, okay? So the first thing when we talk about polynomials, right? So we can say a polynomial, here's our definition. A polynomial is any finite sum of terms. So because, and please note, because subtraction can be written in terms of addition, okay, finite difference are also included in this definition, okay? So maybe I should write that also. Finite difference are also included. So what is this basically saying, right? So a couple things to note. We have something to look at here, what is called a term, okay, or terms. But what do we mean that subtraction, when we say subtraction, can be written in terms of addition? What does that mean? Well, what it's really saying, I can have 3 plus a minus 1, right? And this is the same as if I say 3 minus 1. So that's why we say subtraction can be written in terms of an addition, because here we're adding, okay? But when you combine this positive and a negative, now it becomes a subtraction. So I have a video on sign numbers. You can look at that video on sign numbers to understand more, but that's basically what it means. So when we talk of a polynomial, we're saying a polynomial is a finite set of terms. Finite meaning countable, okay? It's a countable set of terms. So now we may want to think of what is a term? What is a term? Well, a term is a constant, okay, or the product of a constant and one or more variables raised to whole number exponent. So, we said it's a constant, okay? So for example, of a constant, we can say 5 or minus 3, okay? when we say constant, we're referring to just the numbers by themselves. Okay? Now, when we talk about the product of a constant and one or more variables, the product. So what we can think of this here as, example, we have a constant times a variable, because the times means product, right? Or we can have minus 3a. Or we can continue with this and we can say, well, we even have 2, the constant, the variable, and some exponent, 3. Okay, whole number exponents, not fractions. Or we can have minus 7xy to the 5th. So it doesn't have to be one variable or letters. It could be more than one. We can have 4 or 5 letters. We can have minus 8x squared y to the 4th z to the 3rd. Okay? So these are all terms. Okay? Term is a constant. Now, if you understand what a term is, then we can go back to the polynomial definition. A polynomial is a finite sum of terms. Okay? So examples of polynomial now, when we look at polynomials, okay, we can have 2x plus 3. So here, this is a term, and here we have another term. And that's why we say it's the sum. Here we have the sum. Okay? Or we can have example 1/3 xy, which is one term, plus 2x plus 4y. So these are all terms. Okay? Here is one term, here is another term, here is another term. So that's what we really mean by it is a finite set, countable set. Here we have a total of 2 terms in the first example. 2 terms. Here we have a sum of 3 terms. Okay? Now, something you'll notice is that polynomials can be classified further. So we can classify polynomials according to the number of terms present. What this means is that if the polynomial has one term, it's a very unique polynomial. If a polynomial has 2 terms, so we can classify them according to the terms present. A one-term polynomial, okay? So if we have one term polynomial, an example of this will be 2 or minus 3 or 4x or 1/2 a. These are all one-term polynomial. Okay? And if it's one term, Okay, if it's only one term, then we call this a monomial. It is a monomial. So monomial is a one-term polynomial. Yeah. So the polynomial is the general name. It's like if we're in a class, I can say the students of this class. But if I want to call out only one person from the class, then I'll call you by name, right? For example, Tom is one student of that class. So polynomial refers to all the entire group. So monomial is a one-term polynomial. Okay? Then we have two-term polynomials. Okay, two-term polynomial. So a two-term polynomial, example, will be 3x plus 4 or minus 5x squared plus 7. Okay? Or 1/3 x plus y. And for a two-term polynomial, these are called binomial. Two-term polynomials are called binomial. And then we have three-term polynomials. Three-term polynomials. Three-term polynomials could be x plus y plus z, or 6x squared plus 7x plus 3, or minus 5x plus 2y plus 1. So these are all three-term polynomials, okay? And when it's a three-term polynomial, okay, it's called a trinomial. Trinomial. So a trinomial is a three-term polynomial. Now from here, if it has four terms, okay, 4 terms, 5 terms, 6 terms, or anything greater than 3, okay, any polynomials with more than 3, right? More than 3 terms is called a polynomial. Meaning, that is, right, i.e., there is no special name. Okay? There is no special name if it has 4 terms. So for example, if it's a 4-term polynomial, we don't call it a rectanomial or a squarenomial, right? Rectangle, 4 side, okay, or square, 4 sides. So if it has 4 terms, we just call it a polynomial. If it has 5 terms, we just call it a polynomial, okay? If it has 1 term, it is still a polynomial, but the unique name for it is a monomial. If it has two terms, it is still a polynomial, but the unique name is called a binomial. Okay? Now, we also want to talk about the degree. The degree. Degree, okay, of a polynomial. Okay? So the degree of a polynomial, the degree of a polynomial, okay, with one variable is the highest power to which the variable is raised in any one term. Okay? So what does that really mean? The degree of a polynomial with one variable is the highest power. So for example, if we have 5x squared, this here, okay, this is what we call the degree. The power is the degree. Okay? But it has to be the highest power. So that means, okay, that means if we have this example here, 2x squared plus 7x minus 12x cubed, then the degree would be the 3 because it's the highest power, right? The degree is the highest power in the polynomial. So let's look at some examples now, right? Let's look at examples. So suppose I ask you to identify, so one, identify the polynomial, okay, and the degree of each polynomial. Okay. So one, if we have 6x squared plus 2x minus 1. Okay. So a couple of things to note. Here, this is one term. This is another term. And this is another term. So here we have 3 terms. And if we have 3 terms, we know that this polynomial is called a trinomial. Okay? It is a trinomial. So we have identified a polynomial. Okay? Now the degree of the polynomial. Well, the highest power here, because there is a power here of 1, and keep in mind the constant term has a power of 0, right? So the degree of this polynomial, the degree is 2, because the highest degree. Okay? If we look at another example, if we have minus 7x to the 8 minus 5x cubed plus 12x plus 4. So if we look at this polynomial now, we have 1 term, 2 term, 3 terms, 4 terms. So here we have a total of 4 terms. And if it has more than 3, we just call this a polynomial. Okay? We refer to this as a polynomial. I'll write that in the bottom. Now we look at the highest degree. The degree is 8, because 8 is the highest degree. Okay? Another example, how about if we have minus 15? Okay? Well, in this scenario, we only have 1 term. That's it. So here we only have 1 term. So 1 term. And if it's 1 term, right, it is a monomial. Okay, it is a monomial, 1 term. And the degree, well, degree is the power of the variable. Now keep in mind that 15 is the same as 15x to the 0 power, because x to the 0 is 1, right? This is the same as 1. So the degree is 0. Okay, the degree of the polynomial is 0. Okay, because you have to be careful when we talk about degree, right? If you go back, the degree of the polynomial with 1 variable is the highest power to which the variable, very important, to which the variable is raised. The variable is raised. Because numbers by themselves has a power of 1, right? If I write the number 7, it's 7 raised to the first power. Okay? So now that you have an understanding of what a polynomial is, what a monomial is, what a binomial is, what a trinomial is, okay? And the definition, right? The definition that you will see later on for polynomials, the definition is generally written as an x to the n plus an minus 1 x to the n minus 1 plus dot 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 going all the way up to a2 x2 plus a1x plus a0. So this is what you will see later on, especially in a more advanced algebra class, such as pre-calculus, right, or intermediate algebra. So a couple things to note in the definition of a polynomial. These here are the coefficients, okay? These here are called the coefficients of the polynomial, right? So something to note that we generally, or I will say that an cannot be equal to 0. Any one of those an terms shouldn't be 0. Or it can be 0, but we wouldn't write the term. Okay? And the degree of the polynomial, n minus 1, going all the way up to 2, followed by a 1, and followed by a 0. So you will notice that when you write a polynomial, okay, when we write polynomials, power or the degree decreases. Okay, the power decreases, meaning, for example, we write a polynomial as 5x to the fourth plus 2x squared plus 3x minus 1. Notice here the power went from a 4, the 0, there is no cube, then you went to a 2, then a 1, then no power. Okay? So when you write a polynomial, the proper way of writing it is make sure the power is in descending order. The power is in descending order when we write polynomials. That's the proper way. Okay? So in this case, we can now talk about what is called like terms. Okay? So let's now look at what is called like terms. Okay? And sometimes this may call similar to, so like slash similar terms. So when we talk about like or similar, okay, the variable or variables and exponent must be the same. Okay? And what does that mean? This means, class, if we have 2x and 5x, these are like, because the variable here is x to the 1, the variable here is x to the 1. Okay? If we have minus 6xy and 4xy, these are like terms because the variable here is xy, the variable here is xy. Now pay attention to my next example. My next example, if we have minus 3ab and minus 5ba, this may not look like terms, but they are. Okay? Because notice that generally when we write, we don't write BA. The correct way to write is AB. When we write variables, we generally follow the pattern of the alphabet. So this is the same as minus 3ab, but this one here, if you write it correctly, will be minus 5ab. And now, if you notice, the variables are the same. So just something to pay attention to, okay? These are all like terms. So remember, once again, for them to be like terms, the letter has to be the same and the power has to be the same, okay? Now, if you can identify like terms, then addition, subtraction becomes pretty straightforward, okay? So let's look now at addition and subtraction. How do we add and subtract polynomials? So suppose I ask you to add 7x squared minus 2x plus 5 and 8x squared minus 9x plus 6. So here we have two polynomials. Here is a polynomial, okay? And here is another polynomial. Now, there's a couple of ways to do this, okay? And I will do it in what is called the horizontal way. Some of you may have learned how to stack them up the vertical or the column way, okay? So horizontally, we can write this as 7x squared minus 2x plus 5 plus the second polynomial, 8x squared minus 9x plus 6. Yeah? This is called the horizontal. Now you could do column or vertical. Okay? The vertical way, and it doesn't, since we're adding, it doesn't matter which one you write first, will be 8x squared minus 9x plus 6. And in the bottom we have 7. Make sure that when you write this too, that if the like terms must be under each other. Okay? And we will add them. Okay? So I don't like this method too much because there's a few things you will have to be careful. So generally I go with this method. Okay? If you're familiar with either one, you can use either one. Just be careful of your signs. Right? Now, what do? Well, to get rid of the parentheses first, okay? Now keep in mind there's nothing, there's an invisible 1 here, an invisible 1 there, which you should learn later on to distribute. So this becomes 7x squared minus 2x plus 5. And then if you distribute the plus sign, it becomes, you distribute the positive sign to each one of those, you get plus 8x squared minus 9x plus 6. And now what we do, we combine like terms. For example, this like term with this like term. So 7x squared plus 8x squared becomes 15x squared. Please note that when you're adding or subtracting, the power does not change. Okay? It's like money. $7 plus $8 becomes $15, not $15 square or $15 to the fourth power. Okay? So when adding or subtracting, the power doesn't change. The power never changes. And then if we look again at this, let's look at the x term. We have a minus 2x and a minus 9x. Okay? So that becomes minus 11x. Right? And now we have the constant term. The constant term is the plus 5 and the plus 6. So 6 plus 5 becomes plus 11. So please note, right, when I'm adding, I'm taking the sign with each term. Okay? When we combine, so note, when we combine like terms, we keep the sign of each term as we combine them. Okay? Meaning, for example, when we said 7, it was a plus 7 and a plus 8. Okay? And that's how come I got plus 15. All right? So this was how we add. Another example, of adding, we can say find the sum, right? We can say find the sum. So when we say find the sum, we can say find the sum of minus 12x cubed plus 6x squared minus 4x and 10x cubed plus 3x squared minus 12x minus 6. Okay. So once again, we can use the column or the what I call the horizontal method. Now, I like the horizontal method because then we don't mix things up. And what do I mean by that is because if you put them in a column way, notice that this here has a constant term, but this has no constant term here. So just make sure you line up constant term. If you don't see a term, you can put a 0 as what we call a space holder. Okay. So since we're summing, right, I'm going to write the first polynomial, which is minus 12x cubed plus 6x squared minus 4x. That's my first polynomial. And I'm going to add that with the polynomial 10x cubed plus 3x squared minus 12x minus 6. And then I do the same thing as I did before. There is nothing out here to distribute, or there is a plus 1. I shouldn't say nothing. There is a plus 1 out here. Okay. And when you distribute positive 1 to the inside of a parentheses, nothing inside of the parentheses changes. Anytime you distribute a positive 1 to the inside of the parentheses, nothing changes. So once again, there's a plus 1 here. So nothing in that parentheses will change. So 10x cubed plus 3x squared minus 12x minus 6. And then we combine like terms. So first, cube term. Any other cube term here? Yes, we have one more here. Okay. So minus 12 plus 10 becomes negative 2x cubed. Then we go down the line. Next term here, we have a 6x squared. Do we have any other x squared term? Yes, we do. So positive 6, positive 3 becomes positive 9x squared. And then we move down the line again. Okay, we have a minus 4x here and a minus 12x here, so that becomes minus minus 16x. Now be careful. Notice that you still have here this minus 6. And there's no other like terms with it, but you can't leave it out. You have to bring it down. Okay? So this would be the sum of those two polynomials. That would be your sum. Okay? Now, what happens if we're looking, because we want to look at addition. So basically we've looked at addition here. Okay? We also want to look at subtraction. But before we get to the subtraction part, let's look at one more addition, right? How about if I said find the sum of 2x plus 1 3x squared plus 2x plus 4 and 6x squared minus 8. Now, because we have three polynomials here and we're finding the sum of them, okay, the sum, then what we will do is just write them out. 2x plus 1 plus 3x squared plus 2x plus 4, and, which is another plus, 6x squared minus 8. So you could have many polynomials that you can sum up, okay? And then we look on the outside, out here, which is a plus 1. So as I said, distributing plus 1 doesn't change anything. So that's 2x plus 1. Distributing this plus 1 here doesn't change. So plus 3x squared plus 2x plus 4. And distributing this plus 1, we have plus 6x squared minus 8. And now we look for like terms, okay? So now I have a 2x here, and I have another plus 2x here, so that becomes 4x, okay? Then I have a constant term, a plus 1, a constant plus 4, and a constant minus 8. So 1 plus 4 becomes 5, 5 minus 8, that becomes negative 3. And I move down the line again. I have a plus 3x squared and plus 6x squared, that becomes positive 9x squared. But notice that this polynomial here is not written correctly, okay? Because when we write a polynomial, the highest power should be first. So this power here should be first. Now notice when you take it, you always take the sign. So the correct way of writing this will be positive 9x squared, right? Take the sign with it, okay? Then the x term should be next. So this term here should be next, okay? And that is, don't forget, there's a plus sign there, so it becomes plus 4x. And then finally, we have the minus 3, which is here, so that becomes minus 3. Now, we don't usually write the plus sign here, so the final way, or to make it a little bit nicer, 9x squared plus 4x minus 3. And this is our correct way, or proper way of writing it. So these two answers are the same, okay? Same answer. Just this one here is written correctly, okay? Same answer. So those are the various ways of adding polynomial, okay? Various ways of adding. Now let's look at some subtracting, okay? Subtracting. So in terms of subtracting now, just want to point out something to you, okay? Anytime you have a negative sign outside of the parentheses, okay? So for example, we can have 2x plus 4 minus 3x minus 8. Now, I said before that when there's a positive 1 on the outside and you distribute it, nothing in the parentheses changes, okay? But now, because you're subtracting, okay, notice that when you distribute that negative to this term, that little plus becomes a minus 3x. And when you distribute that negative to that negative 8, it becomes plus 8. So know that what happens, as you distribute the negative, all of the signs inside of that parentheses changes to its opposite, okay? So as you distribute, note, as you distribute the negative, all the signs in the parentheses changes to its opposite sign. Meaning that if you had a +3 in the parentheses, it became a -3. If you had a -8, it became a +8. And now we combine like term. 2x minus 3x, that becomes minus x. And then we have +4 plus 8, that becomes +12. Okay? Minus x plus 12. So it's very important to remember this. Okay? If we look at another example, find the difference. Okay, find the difference. Difference means subtract. Okay. So if we have 3x squared plus 7x minus 8, and then minus 2x squared minus 4x plus 7. Okay. So if we get rid of the parentheses, okay, that invisible 1 there, as I said, it's a +1, so nothing in the parentheses will change. But because of this -1 here, all of the sign inside of the parentheses will change. So this becomes, instead of a plus, it becomes minus 2x squared. Instead of a minus, it becomes plus 4x. Instead of a plus, it becomes minus 7. Okay? And now we combine like terms. So 3x squared minus 2x squared becomes 1x squared, which is the same as x squared. We don't write the 1. Okay? Then we have 7x and 4x, that becomes plus 11x. And then we have minus 8 minus 7, and that becomes minus 15. Written in correct order. So this is our final result. Now, let's look at a simple polynomial. Suppose I said in words to you, subtract, okay, 3 from 5. Subtract 3 from 5. Okay, now think about that for a minute. Subtract 3 from 5. Another word for subtract, minus 3 from 5. Another word for subtract or words, take away 3 from 5. So when it's written like this, if you translate it the way, becomes 5 minus 3. So notice the polynomial after the word from is written first. And then we have 5 minus 3, which is equal to 2. Okay? So the reason I'm showing you this example is because when you have polynomials with more than one term, then you have to write this one first, if it's written in this order. Okay? So example, if I say subtract, okay, 4x squared minus 2x plus 3. I don't even need to put it in parentheses, okay? From 9x squared plus 3x minus 5. So the setup, how do you set it up? Setup, okay? You're taking this from this. So you should write 9x squared plus 3x minus 5 minus from that, you're taking 4x squared minus 2x plus 3, okay? Getting rid of the parentheses, once again, is a plus 1, and when you distribute a plus 1, nothing inside changes. But on this side here, you're distributing a minus 1. So all of this sign will change. A minus 4x squared, this becomes now a plus 2x, and this becomes a minus 3. Okay? And now we combine like terms. So x squared term with the x squared term. So 9 minus 4, that will give me 5x squared. And then we go down the line again. We have a positive 3x combined with x term. So that's a positive 3 and a positive 2 becomes a positive 5x. We go down the line again. We have here a minus 5 and a minus 3, and combining them, that becomes a minus 8. And this is written in correct order, so that's my polynomial. 3-term polynomial, trinomial. Okay? A 3-term polynomial is called a trinomial. Now, there is something unique about this polynomial, okay? There's something unique about this polynomial that I didn't say before, which I should have had said something. Notice here, this polynomial, okay, highest power slash degree is 2, okay? Note also, this polynomial has 3 terms. So in general, okay, this polynomial is called a quadratic. A quadratic. Quadratic because the highest power is 2, followed by a power of 1, followed by a power of x to the 0. So I'm going to take that out from here, okay? It's quadratic because we had 5x squared plus 5x minus 8. The only reason it's called quadratic, class, is because the highest power of a 2 followed by a power of a 1, okay, power of a 1, followed by a power of a 0, because here it's really x to the 0. So quadratic highest power must be 2. 2 and only 2. Okay? 2 and only 2. And we'll talk more about quadratics later, but I just wanted to introduce that word to you. And you've probably heard about what is called a quadratic equation, okay? Or the quadratic formula. And that's how in the quadratic formula, the letters you see is A, B, and C, because they're generally 3 terms. One of the terms could be 0, but never the first term. It has to be an x squared term. Okay? We'll talk more about this later, so I don't want to confuse you with this right now. But just keep in mind, in your vocab, there's a new word, quadratic, when it comes to math. Quadratic. Okay? New word. So let's look at multiplying. Multiply or we can say multiplying polynomials. Okay, multiplying polynomials. So you've done this before. So if I ask you to multiply 2x times 4x plus 3. So if you don't recall the properties of exponents, I also have a video online on exponents, rules of exponents. Okay, you can look at that. So now what to multiply means to distribute it. Okay, so if you multiply 2 times 4, this becomes 8. But when you multiply the x with the x, it becomes x squared. Okay, so whenever you're multiplying and dividing, okay, when you're multiplying and dividing, so that's like a little note here. Note, when you multiply and divide, the power slash exponent will change. And this is not so for addition and subtraction. Okay, this is not the case. So if you multiply again, 2 times positive 3 becomes positive 6, and then x here, and there's no x over here, so it just becomes the x come down. Okay. So when you multiply, the power changes. If you look at another example, how about if I ask you to multiply 2x minus 3 and x plus 5. Okay. So if we take 2x minus 3 and we multiply by x plus 5, so now we're multiplying two binomials. Now you've heard what is called the FOIL method, and the FOIL method really means, here, what happened if I only distribute this 2x to the second parentheses? So what is 2x times x? And this here I should write just to make sure that it looks the same. It's x. Let's put that back in black. It's x plus 5, because in math you have to be careful. Okay, in math, this x and this x here are two different x's. Okay, you're not supposed to mix them up. So 2x times x becomes 2x squared. And this is where the word, what I'm doing is foiling this, right? Meaning the first term in each polynomial. The first, okay? And then we continue again. Take the first term and distribute to the second term, okay? And that's where we have the O. Maybe I should redo that. Okay, so I'll put the F here. Okay, when I do this again, I do this and this now, and that's where the word O comes in, meaning the outer terms. So 2x times a positive 5 becomes a positive 10x. Okay? And then there's nothing else to distribute that 2x to, right? If this was a trinomial, then we keep distributing the 2x, but there's nothing else to distribute it to. So now we move to the minus 3, and we distribute. The inner terms now, inner, right? So we did F, we did O, so minus 3 times x becomes minus 3x, and that's the I, okay? And then we go again, the minus 3 times the 5, which is what we call the last thing to do. Minus 3 times positive 5 becomes minus 15. That's the last. And that's how you came up with the word FOIL. I'm not a big fan of FOIL because it only works when you multiply two binomials, right? So I don't like to remember something that only works once. Only for two binomials you can use FOIL. Now, if you notice here, we have what is called like terms. So I could rewrite this as 2x squared plus 10x minus 3x becomes plus 7x minus 15. And here is our trinomial known as a quadratic. Hey, we have another quadratic. Yeah? We have another quadratic. So look at another example. Multiply 2x minus 1 times, so a binomial now, 3x squared minus 4x minus 5. So in this case, we cannot say FOIL because this is a binomial, 2 terms, and this here is a trinomial, 3 terms. But the idea is the same, okay? What I said to you earlier, take the first term and distribute it to everything inside that second parentheses. So 2x times 3x squared becomes 6x cubed. Okay? Then we do this again. What is 2x times this? So 2x times minus 4 becomes minus 8x squared. And then we do it again. 2x times this. 2x times minus 5 becomes minus 10x. So there's nothing else to distribute that 2x to. So now I move to my minus 1. Okay? Minus 1 times 3x squared becomes minus 3x squared. Minus 1 times a minus 4 becomes plus 4x. And minus 1 times minus 5 becomes plus 5. We're not quite finished because I see we have like terms. So first, we have a cube term. Any other cube terms you see? I don't think so. So we bring down that cube term, 6x cubed. Then we move to other terms. Here we have a square term. Any other square terms? Yes, we do. Here we have a square terms. So minus 8 minus 3 becomes minus 11x squared. Okay. Then we move down the line again. We have a minus 10x and a plus 4x. So minus 10 plus 4 becomes minus 6x. And then notice you have this lonely term out here, plus 5. So we can't leave it out. We have to bring it down. So this is my quadratic. 1, 2, 3, 4 terms. It's a polynomial. Okay, no special name. Okay. Now, sometimes what can be confusing, okay? sometimes what can be confusing is if I say multiply, okay, x plus 3 quantity squared. Quantity mean everything is in parentheses. And generally we don't say the word multiply so much here. We may say expand, okay? So keep in mind, what does this mean? This means write that parentheses twice, right? Because of the square here. So it's x plus 3 times x plus 3. And now you can FOIL this out, okay? Because we now know how to FOIL. X times x becomes x squared. X times 3 becomes plus 3x. There's nothing to distribute this x though, so now we distribute the 3. 3 times x is 3x. And 3 times 3 is 9. Combine like terms that we have in the middle, okay? We have x squared plus 3x plus 3x is 6x plus 9. Okay? So you notice when you multiply it, we have 3 terms, right? This is the first term. Here is the first term. Here is the second. There's the second term, and here is the third term. Okay? And we can say that this here is the first term. First term. This is what we call our second term. In this case, it's also the middle term. Okay? Or second term. Second term. AKA middle term. Here we have our third term. Okay, or AKA last term. Okay, so the first, second, and third, or first, middle, last. Okay, now if you look at what we had before, right, shortcut, how about a shortcut? And we had x plus 3 squared. Yeah. Now we know when we multiply this, we're going to have 3 terms. Okay. And to get the first term, to get that first term, so let's say the first term goes here, the second term goes here, and the third term goes there, right? So this is going to be my first term. This is going to be my second term. And here is going to be my third term. Now the first and the third is easy to get. So you take this here. To get the first term, we square it, because this is a square. To get the last term, we take the last term in the polynomial, okay? The last term in the polynomial, and we square it. and that becomes 3 squared, which we know is 9. The question is, so this becomes x squared, and this becomes, it's a plus 3, right? So that becomes plus 9. The question is, how do we get the middle term? Now, to get the middle term, you take this 2 and you multiply it by the first term times the second term. So this 2 is here, the x is there, and the 3 is there. And that becomes, they're all positive 6x, right? 2 times x is 2x, times 3 is 6x. So we have x squared plus 6x plus 9. Okay. So it's a nice, and that's the same thing we had before, right? X squared plus 6x plus 9. So it's a nice little shortcut once you get the hang of it, right? The shortcut is really nice because we can get the hang of this. Okay. Let's look at an example again. Example. Let's multiply. But I said I don't like the word multiply too much for these, or when it's written in this form, we say expand. Okay. 2x plus 3 quantity squared. Now, a couple of things to note. Because this is a 2, you're going to have 3 terms. 1, 2, 3. Okay? Now, what goes in the first term? So be careful. The first term is 2x and you square it. Okay? To get the last term, you take 3 and you square it. Now, what happens to the middle, right? The middle, you'll get 2 times 2x times 3. And notice they're all positive. So if you square this, you get 4x squared. If you multiply these two, you get 4x times 3. This becomes plus 12x. And if you square this, maybe I should write it out. It means 3 times 3, you get positive 9. So let me write this out for you here. You get 2x times 2x. Alternatively, right? Alternatively, you could have said this is 2x plus 3 times 2x plus 3, and you could have foiled it out. Okay. Now, since we will move to a more advanced level, I prefer if you get to know the shortcut. Okay. This here is the shortcut. Or you could multiply to foil it out. 2x times 2x becomes 4x squared. 4x squared. Then 2x times 3 becomes plus 6x. Then 3 times 2x becomes plus 6x. And 3 times 3 becomes plus 9. And notice that we have like terms, so we have 4x squared plus 12x plus 9. Okay. So this is the reason I like the shortcut, because you'll be able to get the hang of this after you do a few examples. Okay. Now, we could have where the power here is bigger than 2. You could have a scenario where the power is 3. Well, what do you do in that case? Suppose I asked you to expand 5x plus 2 cubed. Well, there is a cubic formula, okay? There is a cubic formula which you will also learn. But before we get to the cubic formula, keep in mind that this is the same as 5x plus 2 times 5x plus 2 times 5x plus 2. Okay? And if you know how to fall this out with a shortcut. So you could multiply that out first. And if you multiply that, you'll get 5x squared plus 2 times the 5x times the 2 plus 2 squared. Okay, we didn't touch this part here yet. So this is going to come down as 5x plus 2. If you simplify this, you will get, because this is 5x times 5x, so we have 25x squared, and plus 2 times 5 is 10x, plus 2 becomes plus 20x, plus 4. And now we multiply this by 5x plus 2. So just in case you don't remember the formula, right, there's the long way to do this. So now if you multiply everything by the 5x times every single thing in here, what do we get? Well, 5x times 4 becomes 20x, or we could start from this side first, it doesn't matter. 5x times 25, 525 is $1.25, x cubed. 5x times the 20 becomes plus 100x squared, and 5x times 4 becomes plus 20x. And now we distribute the 2. Okay, so this becomes 2 times 25 becomes plus 50x squared. 2 times 20 becomes plus 40x, and 2 times 4 becomes 8. And if we combine like terms as we did before, here there is no x cubed, so that's the only one, 125x cubed. If we look again, we have square here and we have a square here, so this becomes plus 100x. 100 plus 50 is 150, 150x squared. And then if we move down the line, we have 20x plus 40x, and that becomes plus 60x. And don't forget the plus 8, we bring it down. So now, what is the formula for cubic? And if we apply that formula, what do? Well, the cubic formula, what happens if we have a plus b quantity cube? Well, this we know is the same as a plus b times a plus b times a plus b. Okay? And if you expand this, you will get a cubed, okay, plus 3 a b squared plus 3a squared b plus b cubed. So notice that there's a lot happening here, right? There's a lot happening here. Now, another way of writing this, you could say a cubed plus 3a squared b plus 3ab squared plus b cubed, right? These two terms can interchange. It doesn't matter. Those two terms can interchange. What's unique, and I'm not gonna get into the cubic formula right now. What's unique about this, a is 3, a is 2, a is 1, a is 0 power here, a to the 0 power, so we don't need to write it. And then what's unique, b to the 3, b to the 2, b to the 1, b to the 0 power here. Okay? So that's very unique about this. In addition, right? In addition, if you add the powers of these two terms, what do you think you were going to get? Only the powers. Okay? So the power here, power will be 4. Oh, sorry, power will be 3. Power will be 3. Power here is 3. Power here is 3. Power is 3. And that's because 3. Okay? So as we do examples, or if you want to learn more about this, you know, we can talk about it during office hours. Okay, but my goal here is to show you how to multiply and to show you that there are formulas to multiply. There's shortcuts to multiply. So generally, you know, polynomials can also involve fractions, right? Polynomials can also involve fractions, so we should do some example with fractions. How about if I ask you to, this is an example, multiply, okay, 1/2 x plus 1/3 times 3/4 x plus 1/3. So generally when we see fraction, we already start to like get scared, right? A lot of people are afraid of fractions, but if you take your time, it shouldn't be of a major problem. Just take your time. Don't freak out. Okay? Now, we know that we have to multiply the first term with the first term. Okay? So if you want, you can do some scrap work. There's nothing wrong with doing scrap work. Okay? What happens when you multiply 1/2 times 3/4? Okay? Well, 1 times 3 is 3, and 2 times 4 is 8. You get 3/8. So when multiplying these two, you're going to get 3/8 x squared, right? Because we have an x to the 1 and x to the 1. And then we multiply again. What happens when we have multiply 1/2 times 1/3? Well, 1/2 times 1/3, 1 times 1 is 1, 2 times 3 is 6. So we have plus 1/6 x. There's nothing else to distribute the 1/2 to, so now we move to the 1/3. What is 1/3? What is 1/3 times 3/4? Well, 1 times 3 is 3. 3 times 4 is 12. Okay. And this can be simplified. This can be simplified to 1 over 4, because you can divide here by 3, you can divide here by 3. So here we have plus 1/4 x. And then if we multiply again, 1/3 times 1/3, what is 1/3? Okay, 1/3 times 1/3. Well, 1 times 1 is 1, 3 times 3 is 9. So this becomes plus 1/9. Now, notice that you still have a little work, right? Because here is an x term and here is an x term. So you have to add these two. Okay? You have to add them. So how do you add now 1 over 6 plus 1 over 4? Well, you have to find a common denominator. The common denominator is 12. So 6 times 2 is 12, so you have to multiply the top by 2, so this becomes 2. 4 times 3 is 12, so you have to multiply the top by 3, that becomes 3. And now 3 plus 2 becomes 5 over 12. So the final answer is 3 over 8x squared plus 5 over 12x. Don't forget the x, because each one of them had an x, okay? Plus 1/9. So yes, it is a little bit more work, especially scrap work, okay? But it's doable. Okay, it's more scrap work, but it's doable. So keep in mind that polynomials does contain fractions. In addition and subtraction, they do have fractions. Okay. Now, so we have looked at the addition, we've looked at the subtraction, we've looked at the multiplication. We haven't looked at division yet, because I'll come back to that later on. But we can also do division of polynomials. And division is the same as multiplication, just we multiply by the reciprocals. But then too, if we're talking about division of polynomials, we could end up with what is called long division. Yeah? So division is a total, I want to leave that for a video by itself. Okay. And since this is just a review, I'm not really getting into the division part that much. So hopefully with this video, okay, you have a good understanding of polynomials. Okay. If we go back to look at our objectives, you understand what is a polynomial now. Okay. So it's a finite sum of terms. Okay. Finite sum of terms. And you can even add, based on the definition, you should add to that where none of the exponents are negative, right? Remember, I give you the definition of a polynomial. Here, maybe we should highlight that. Definition of a polynomial. So something to note about it in the definition of a polynomial, every single n is positive. The power, okay? The power of n is positive. So in polynomials, if the power is a negative, it is not really a polynomial, okay? So we do know what a polynomial is, right? We know what a term is. We looked at monomial, binomial, and trinomial. Monomial is a single-term polynomial. A binomial is a two-term polynomial. A trinomial is a three-term polynomial. And we've also looked at how to add, how to subtract, and how to multiply polynomials. So you can try some more examples of this on your own. Remember, practice makes perfect. Okay. and I hope this is helpful to you.